Welcome to another day on the Journey chez Chem. Please do the 2 warm-up questions to the best of your ability, and we will discuss them in a moment. Number 1 is just a big fat conversion, and we've had conversions before, only now we're talking about moles and compounds. It's getting a little bit more abstract, but it's the same principle. I'm starting with 3.25 times 10 to the second formula units of lithium carbonate. From formula units are tiny particles, and I must change them to moles. And 1 mole of lithium carbonate is 6.02 times 10 to the 23rd formula units of lithium carbonate. That gets me to the mole central. For mole central now, I'm going to mass, and I need to know the mass of lithium carbonate. I have 2 lithiums, and each lithium has a mass of 6.9. Carbon is 12.0. And there are 3 oxygens. There are 3 times 16.0 AMU. I write these out again, and this is 13.8 and 12.0 and 48.0, and I add them all together in order to get my gram formula mass. And it comes out to be 73.8 grams per 1 mole of lithium carbonate. And grams is what I'm looking for. 73.8 grams of lithium carbonate is 1 mole of lithium carbonate. Now, when you are going to have a worksheet that you are going to take home and do to be turned in and graded, these problems are worth 10 points. And 2 points for the conversion to formula units, to moles, and then 2 points for changing it to grams, 2 points for the answer, and we need to solve this. I need a calculator. I've now returned with my calculator, and I calculated this number already, and I got 3.9842 times 10 to the negative 20. And in my numbers, I always go 4 places past the decimal first before I round to the correct number of significant digits. I look back at my original problem, and my answer should have 3 significant digits. And therefore, it is 3.98 times 10 to the negative 20th grams of lithium carbonate. And as I was saying, when these are 10-point problems, 2 points for the conversion to moles, 2 points for the conversion to grams, then 2 points for the correct number of significant digits, 2 points for the unit, and 2 points for the compound. And we'll be checking that you've done everything exactly as I've shown. That's number 1. In number 2, I'm changing my grams of zinc acetate to formula units of zinc acetate. And the first place I have to go is mole central, and therefore 1 mole of zinc 2 acetate is the AMU, and I must add up the formula mass. Zinc is equal to 65.4. There are 2 times 2 is 4 carbons, 4 times 12.0. And I have 6 hydrogens, 6 times 1.0. And 4 oxygens, which is 4 times 16.0. Then I'm going to multiply them out, because remember, it's where the formula mass is where oftentimes mistakes are made. And I get 65.4 and 48.0 and 6.0 and 64.0, and when I add them all up, I get 183.4 AMU, or grams per mole. And that would then go on the bottom here. That gets me to moles. And then from moles, I'm going to formula units. And I know that 1 mole is always Avogadro's number of formula units of zinc 2 acetate. And you can see that every time I write out the compound, and that's just a very good habit that we need to establish. Now, when I do the multiplication and division here, 26.32 divided by 183.4 equals times 6.02 exponent 23 equals 8.6393 times 10 to the 22nd. I look back at my original problem, and there are 4 significant digits here. Therefore, I have to go 5 and determine if I will round this up. And a 3 does not round up. Therefore, my answer is 8.639 times 10 to the 22nd formula units of zinc 2 acetate. Now, zinc is always plus 2. I don't need a Roman numeral 2 because it's always, always, always. It's one of my silly 6. And it's just zinc acetate. Again, this problem could be worth 10 points. 2 points for changing it to moles. 2 points for going to formula units. 2 points for the correct number of significant digits in my answer. 2 points for the unit and 2 points for the compound throughout. And that's how you do those problems. And I know that you're going to do well on your assignment, and I can't wait to see you tomorrow. Bye!